All right, Carter, in the third hour, this one is for you. So here are the answers. For this first question, I'm going to tell you right now that on the summative assessment, you're going to be given a graph. I included all three types because it's important you see all three types. You should be able to tell me if it's exponential, linear, or quadratic from an equation, from a table, or from a graph. But the graph is the one that I'm focusing on. So remember, exponential graphs have that J curve. Linear graphs are a straight line, and quadratic graphs are the parabola. For the graphing portion of it, to get a 2, so this is the 1, the 2, you have to be able to find that vertex points and choose numbers before or after to get all 4 of the other points. To get a 3, it's the graphing, which is really the easy part. So here I have to pull out my A, my B, and my C. So my A is 1/2, my B is 2, my C is 3. So the opposite of B over 2A is how I find my x coordinate. So the opposite of 2 is -2, and then 2 times A is 1/2, 2 times A is 1, so my vertex point is a -2. Now because this is a fraction, the leading coefficient A is a fraction, I'm going to choose numbers that are easily divisible by that denominator. So if it's -2, I just did my even numbers, -4, -6, 0, and 2. And then I plugged the numbers in. You know how I do this. I did all of my 1/2s and then my parentheses and then plus 2, 2, 2, 2, 2, etc., all the way down. And then I plugged in. Now here it was easy for me to just square it right away. So -6 squared is 36. And then I plug the -6 in there. And then off to the side over here, I didn't want to do too much in my head, and I didn't want to rely on my calculator. So 1/2 times 36 is 18. 2 times -6 is 12, plus 4. And then I simplified that. Once I have these numbers, all I have to do is plot. Remember, if you don't have a pattern here and you don't have that parabola, then you know you did something wrong. If you have this whole section complete, and you have it right, and you don't make any arithmetic errors tomorrow, you should be guaranteed a 3 for this learning target. I see now when I took the picture of this, I cut off the bottom part, but the key for 5 is on BB9. So look at the answers for this one, and I'll just talk through it. It is similar to 4. Okay, so for this learning target, to get a 1, you have to be able to name the A, the B, and the C. Please do not forget to put it in standard form first. So for example here, 4 is not in standard form. So you needed to put it in standard form first and then pull out your A, your B, and your C. After that, you are going to plug in. So B is 9, so the opposite of 9 is -9, plus or minus. B squared is 81 minus 4 times A, which was 1, times C, which was 20, all over 2A. I am still seeing some of you forget that all over 2A business. So 2 times 1 is 2. Then I'm going to simplify this part. So 81 minus 80 is 1. And then I'm going to split off. So I have -9 plus 1 over 2 and -9 minus 1 over 2. So -8 over 2 is a -4, and -10 over 2 is a -5. The only difference between 4 and 3 is you needed to put it in standard form first, and then pull out your A, your B, and your C. And I believe this did not come to, oh gosh, this picture is awful. This did not come to a perfect square, so don't forget to be very careful with your arithmetic. Okay, and then 5, what are the x-intercepts? Again, the only difference, oh, I guess this was a perfect square. The only difference between 3, 4, and 5 is you have to start by putting 0 in for y. So here I changed this y to a 0. Then I pulled out my A, my B, and my C, plugged in, and I had 4 plus or minus the square root of 52 over 2. And so in the calculator, I did 4 plus the square root of 52, enter, divided by 2, and 4 minus the square root of 52, enter, divided by 2. If you plug in the square root of 52 and then round it right away, your answer is going to be less correct, so please don't do that. All right, applications. I have a feeling the applications are the part that you really wanted me to talk about. So for 6, an object is dropped at an initial height of s feet. So I gave that right to you in there. The object's height at any time t is given by this. So how long does it take for an object drop to get to 300 feet to hit the ground? So to get a 1, all you have to be able to do is put the numbers in the right location. So s is the initial height. That's 300. So 300 goes in for s. Hitting the ground is 0. That's your h. So from here, some of you on the formative used the quadratic formula, but remember, this does not have that middle t term, so we can just solve by finding the square root. So I subtracted 300, I divided by negative 16, and I took the square root of both. The square root of 18.75 is a positive 4.3 approximately and a negative, but the negative doesn't make sense. So we're just taking the positive answer here. 7, a falling object. Your cousin is riding on a glider at an altitude of this, 1,500 feet. So that's our beginning. That's where she is right now. He throws. So this is our beginning, our S. He throws a rock. That means there's an initial velocity straight down towards the water. When the rock leaves his hand, its speed is 20 feet per second. How long will it take to hit the water? To hit the water, that's at 0. Our height is 0. So I'm going to plug in, if this is my S, I'm going to plug that in for S. And because he was throwing it down, that is a negative velocity. So V is a negative 20. It goes right here. And then from here, it's just like the last learning target where you pull out your A, you pull out your B, you pull out your C, and you plug it all in. The only thing that makes this difficult is the big number, but you can use a calculator. So the opposite of negative 20 is 20, plus or minus b squared minus 4 times a times c, all divided by 2a. 2 times negative 16 is a negative 32. Once I work this all out, 20 plus or minus the square root of 96,400 over negative 32. And I'm going to do that 2 times. I'm going to do 20 plus that square root, enter, divided by negative 32, and 20 minus that square root, enter, divided by negative 32. So I have 2 answers. The negative does not make sense because we can't have a negative time. So it is going to be this positive 9.1 seconds. The beginning part of 8 is very similar to what we just did. This time, however, it is being thrown upward at an initial height of 3 feet, has a velocity of 70. How long will it take to return to the ground? The ground level is 0. It might have asked how long would it take to get to 100 feet. All times it is 100 feet, so you'd have 100 there. In this case, it says ground level, so you're putting 0 in here. Here is your initial height of 3 feet, and then your velocity, since we're throwing upward, is going to be 70, a positive 70. So after you plug in the numbers, you pull out your A, your B, and your C, and then you do the opposite of B, so the opposite of 70 plus or minus 70 squared minus 4 times A, which is negative 16, times 3. Once you simplify all this, again, this is where you have to be very careful with your calculations because this is not a perfect square, so you're going to do negative 70 plus the square root of 5,092, enter, over negative 32, and negative 70 minus the square root of 5,092, enter, over negative 32. There are 2 different answers, negative 0.04, so it was at ground level at negative seconds because we started 3 feet up, and it was at 4.4. So it would be the 4.4 seconds because negative time does not make sense. And the maximum height, anytime you have the maximum height or the distance between, anything like that, you have to think of what that parabola would look like. So you start at 3 here, we're looking for that vertex, that maximum height. Now t, remember, is the seconds. The h, or the y variable, is the height. So I had to find the x-coordinate of the vertex, so the opposite of b over 2a, and I found that. And then I had to put it back into the equation because I wasn't looking for how long. It took us 2.1875 seconds to get to that highest point. We were looking for the height, so we had to plug it back into this equation. So here is my x, or my t in this case. I plugged it back in, and I just really used the calculator here, negative 16 times 2.1875 squared plus 70 times 2.1875 plus 3. Because if you're using a calculator that does the order of operations, it should work out perfectly. If not, do one piece at a time. And I ended up with 79.56. It was not seconds, so I apologize for that. It was feet. I did not notice that. So 79.56 feet. All right, so that was that learning target. And the last learning target is quadratic inequalities. You have to be able to find the vertex, find your points, plug it back in. I think the big thing to be proficient is you have to know dashed or solid. In this case, you can't see it here, but it was a dashed because it was the less than, and you need to be able to shade correctly because this was a greater than. I knew that I was going to shade everything above that parabola. So other than that, it's exactly like the learning target, just graphing quadratic equations, where you have to do the opposite of b over 2a to find your x-coordinate, and then choose numbers before and numbers after, plug it back in to get your y's, plot, but then with inequalities you have to remember shading and dash or solid. If you can do all of this, you should be able to have a 3 on each learning target. Remember, I have not included any of the 4-level stuff on here. Hope that helps. Have a good night.